Yeah.
I keep your hoe upstairs. When she wanna fuck, I just tell her ring the bell. Hit her from the back, she
Alright. Okay. Sorry about that. Alright, so in this video, we're me going over this section of the Game Hacking Academy. But before we go over this section, we're going to do a couple of things real quick for the game. What is this? Well, I guess I'll keep this right here. I'll just use this. Alright, so we're gonna need to open up Cheat Engine real quick. And alright, so I'm not gonna be doing the Wesnoth one. I'm just gonna be doing Assault Cube because it's just an easy game and I have it on my computer. And yeah, I'm not gonna be installing Wesnoth. And I'd like to focus on 3D games and not 2D games in the first place, and games that you can make an ESP aimbot for. So anyway, so before we do this, we're gonna need to go get the base address and the offsets necessary to get our player's health value instead of gold. That's what we're gonna be doing. So I'm gonna show you how to get this real quick. I already know how to. It'll be pretty easy. We're just gonna crack ourselves out with a couple of grenades. I've done this probably a million times at this point in my life, so okay, it might already be saved on there. Whatever. Let's scan for 100 health. Goes over the grenade real quick. Okay, 29. Okay, so this is the one we're looking for. Find out what accesses. Okay, so EDI is gonna be our pointer, our local player pointer. We're now gonna do a new scan. We're gonna scan for this. So these right here are base addresses, or static addresses that lead to the value of our pointer. So alright, so now we have the static address, which is just this, and then plus, what was it? Plus EC. Plus EC, so it'd be, and our cheat is gonna look something like this. It's gonna be AC units for client. Well, we're gonna rename this to like, yeah, you get what's gonna be. It's gonna be something along these lines to get to our health address. So we can just close this out now. Yeah, we can save that, sure, there. Save that to here. Okay, cool. Alright, now that we've done that, we can go into this thing, external memory address. Real quick. Alright, so some memory hack. Targeting this lesson will be. No, I'm not gonna play music. Alright. In this lesson, we'll create a C++ program that will modify a player's gold in Wesnoth. And then defeating DMA lesson, we defeated DMA in Wesnoth and located the player's base pointer at 0x017, whatever the fuck. We determine the offset necessary to locate the player's gold from the base pointer. That's what we just did. So this is our base pointer to our local player address. Then plus EC is to our health address. Since these addresses are and offsets are static, we can create a program to perform this operation. We covered several approaches to do this in programming fundamentals lesson. In this lesson, we'll create an external executable. To create C++ programs, we need a compiler and a linker. Compilers to determine high-level language code and opcodes. And linkers to create an executable that the OS understands. And these opcodes, these two components are normally bundled into an integrated development environment, or IDE. IDEs contain other components as well, such as code completion and interactive debugging. Visual Studio is an IDE, integrated development environment, that Microsoft has released for Windows. The Community Edition is free to download and use in personal projects. It can be installed using Chocolati, which we installed when we first setting up the VM. To do so, open up command prompt or PowerShell and follow command. We don't need to do none of this shit. You should, if you're watching this video, I would hope you already have Visual Studio installed. But let me close it out. I'm not gonna be working on that in this video because this is gonna be an external. So I'm just gonna, yeah. In Visual Studio, source code files are contained within projects. Several of these projects can be contained within the solution. For example, the Visual Studio solution for Wesnoth might look like game solution, engine project, player.cpp source code, or main.cpp source code, UI project, network project. This is talking about how our solution is going to look when we create our project. To create a C++ solution, we will first need to install some C++ components. It can be done by selecting install more tools and features link, then selecting desktop environment C++ in the install wizard. And right here. These components installed, we can now create C++ projects and compile them, creating projects. Once these components are installed, create an empty C++ project and name it external memory hack. Alright, so let's just create a project. Just make an empty project. Let's call it external memory hack. Okay. Alright. With the new project created, we can now add our source code that will contain all our code to do so. To do this, right click on source files and add. I'm not gonna do that because I don't like to use the pre-compiled stuff and make my own folders real quick. I'm just gonna make a file called source and we'll just add. What does it want us to add? Add new item in the model that appears, choose this file and name it main CP. Okay. Why do I keep pressing tab and fucking add main CP in here? Okay, so we're adding main CP and we can have begin program. C++ basics. C++ has many features and is a versatile language. For our purposes, we will focus on the most important ones for creating hacks. For this lesson, we need to know two things with the language. Programs start with a function called main. This function is to return a value. And programs can call their functions built into Windows. Any C++ executable needs to have a main function that returns an integer. This function takes two parameters, which are not important to know at the moment. When executed, the OS looks for executes this function. When the function returns, it signals to the operating system that the program is finished. Execute in addition to functions we create, we can call other functions that are built into Windows. Windows has many APIs to do things like displaying text, playing sounds, and creating files. Windows also has APIs that allow us to read and write values to an address in the process. These are what we will use to create our hack. To use these functions, we need to include certain header files. Header files contain definitions for functions that are defined outside of our source file. To read our memory, we need to include the header file Windows H. Okay, before we do this, let's go and fix up our thing real quick. You don't have to do these if you don't want to. Well, you do have to do these actually, but where is it? No, it's not there. Is it a linker? Okay, yeah, system. We want to change system to a Windows subsystem. So when you run on Windows, that should be good. Alright, by examining this documentation, we need to read several values and was not okay. To use this function, we need to include certain header files. Header files contain definitions of functions that are defined outside our source file. To read and write memory, we need to include the header file windows.h. So just come to the top of your program, ncp hashtag include windows.h and main. Okay. So we need to read several values in WesNoff to locate our gold value. The API to read another process's memory is called read process memory. If you Google this name, the first result will be documentation from Microsoft. Documentation describes how the API works, including what parameters it takes and what value it returns. By examining this documentation, we can determine what values we need to provide. For any values we still need, we can then determine how to get them. The Win32 coding style conventions documentation provides information on how each parameter is formatted and named. Pull it up real quick. This is just gonna go through just a bunch of shit. I'm not gonna bother with that. Process memory function is definition is bold read process memory, takes a handle H process, LPC void, the base address of LP void, LP buffer size, size underscore T, size underscore P, pointer to LP number of bytes read. Looking at the code block above, we can start at the first parameter and work our way down to determine values we need. First, we do not have a handle to a process, so we need to do that. We will discuss how to do this in the next section. We have the base address. In this case, our base pointer, the buffer needs to be provided by us, so we need to recreate that. The size parameter will be the size of the data to read. In this case, size will be 4 bytes for the size of the registers we saw while we're reversing. So yeah, but if you want to know why it's 4 bytes, so it's for one, we've been working on, well, for a salt cube, it's a 32-bit integer, so it's gonna be 4 bytes, right? It's a D word. It's gonna be 4 bytes. And yeah, and it's also x86, so we're not gonna be doing 64-bit integers, which should be 8 bytes, right? Anyways, while this might seem overwhelming, this gives a starting point to program from. First, we know that we need to include Windows.h so that we can use read process memory. Did that. Next, since it's a C++ executable, we will create a main function. So let's paste this into the parameters. So it's going to be taking an integer type of argc and a char pointer to argv. Okay. Finally, in the main function above the return statement, we can insert our call to read process memory. For values we don't have yet, we will put in a variable name. As we figure out how to retrieve these values, we can then assign these variables. Finally, in the main function above the return statement, we can insert our call to process memory. For values that we don't have yet, we will place the variable names to figure out how to retrieve these values. So, read process memory wasnoth underscore process. Opening processes. When is it? So it gets a handle. Wasnoth underscore process. It's open process all underscore true process ID. Okay, yeah. So it's gonna be defining wasnoth later. So I'll do basically the same thing it's doing here. Let's just go to here. Alright. Let's do read process memory. We'll do we'll just call it, I guess we'll just do the same naming convention. We'll just do AC underscore process, and the offsets are gonna be did not save it. Oh no, I did. Okay, so maybe the offset right there we're using gold under, or we just not get help underscore value. I'm gonna read what it's saying because it's an LA. So 4 bytes underscore red. Okay, let's just get rid of it. Yeah, a lot of these things haven't been defined yet. So I'm gonna fix. I'm not gonna do it like that. It's kind of annoying to try and look at, to be honest with you. Alright, our next step is retrieving a process handle to do this. We use an API called open process. Definition for this API is what, my bad, I forgot. Wait. Down. Both the gold underscore value and bytes underscore red values are provided by us, populated by the API. Therefore, we need to initialize 2 variables to hold these values. So we're reading 4 bytes. These variables need to be large enough to hold amounts of the size. One option to accomplish is use a D word, which is 32 bits or 4 bytes long. Declarations above the call to read process memory. So let's just make a D word. So let's make a D word for help underscore value. Make a D word for bytes underscore red. Well, I guess we have to, I forgot to initialize them. My bad. You know, get all the initializer variables. Okay, this is code primitive type. Let me make this. Argument type D word, aka unsigned along with the code type of LP void, aka void. What is this thing talking about? It's because we need to make it. At the address. Argument type anything that will type LP void, aka const void. I'll fix that in a second. Both these parameters are expected to be pointers. We need to also change our read process memory call. Instead of passing the variable's value, we need to pass the address of these variables using at sign. Our next step is retrieving a process handler. To do this, we can use an API called OpenProcess. The definition of this process is handle open process, the word desired location, bool inherited handle. That's the this definition. We can see that open process returns a handle to a process. This handle can be used as the first parameter to read process memory. Looking at documentation, we want our desired access to be process underscore all underscore access that we can both read and write to the process. Second parameter does not matter for what we were doing, so we will set it to the value of true. We will need to find the last parameter, so now we will create a variable. So we need the result of this function to call read process memory. We will place the call to it above read process memory. Our code should now look like. So yeah, so we're gonna get a handle for this. So we're gonna put a handle. So let's do it right here. Handle AC underscore process equals open process desired access. It's gonna be process underscore all access. So we can do it self all underscore access. Okay. Bool inherit handle. True. And then we're gonna pass it process ID. Alright, I forgot I'm using snake case from now on. Alright. Next, we'll retrieve a process ID for the open process call, similar to the previous two APIs. We'll use another API and then fill in any information we need. In this case, the API will be get window thread process ID. This API retrieves a process ID when provided with a window handle. It is different than the process handle. The definition for this API is, I'll just open these all up. It's going to be MSDN. So get window thread process ID function when user retrieves the identifier of the thread that creates the specified window. Optionally, the identifier of the process that created the window. D will get process ID. So we're going to give it an N. So a handle to the window, parameters, handle to the window, type handle to the window. Return value, type D word, type LPD word, pointer to a variable that receives the process. So we need to give it pointers. Okay. So this function requires a handle to a window and a variable to hold the process ID. Before we will add this code above our call to open process. Get window thread process ID. Was not underscore window. Yeah. So we can just do. So we already have our process ID right here. Just hit this up. Get window. What's it called? Get window thread. Get window thread. Get window thread. Oh, we don't need it just as a D word. It's me pulling it from get window thread process ID. And we're gonna pass in AC underscore window and the process underscore ID. No, we have an at sign because it's an LP void. So we don't have AC underscore window defined yet, but to get a window handle, we can use the API find window. This is tons of APIs, my god. We can use the API find window. This function takes the name of a window title and returns the value to the window. Definition is handle to window find window A, class name window name. So since we want to search all windows, we will set the first parameter to null. Second parameter, we know the name of both not the windows. It's probably going to be inside of bar. We can search it's find. So yeah. Okay, so yeah, we can just do. Let's set at the top like how they did right here. H. H wind AC underscore window is equal to find window. So we're gonna do find window. Null. Then result cube. The reason I'm putting an L here is because I'm not using multi-byte. For me and my friends, we all use. It should be, where is it at? Is it in here? Code generation. Language. Okay. Yeah, we all use a Unicode character set, so that's what I'm gonna be using. So I had to put an L there to make it a W char underscore T. So that one these here. So that should be everything filled out now. AC underscore windows filled out. At to the process ID. Process ID we haven't set up yet, so forgetting mine. Okay, we'll get to that in a second. Casting parameters. Visual Studio will display several errors for the code we have written. This is because we have not properly casted two of our variables. As a result, the crowd can understand how we want to pass data to a function. If we want to compile our program, we need to fix the errors. Luckily, by reading the error list in Visual Studio, we can determine what we need to fix the errors. It's just the two read process memory errors that occur on line 13. Okay, the first error for line 13 is argument type int is incompatible with parameter type LPC void. It indicates that we have a parameter that is an integer that's supposed to be a LPC void. Second error cannot convert argument 2 from int to LPC void, indicates which parameter this is. Argument 2 is our address. If we Google LPC void, the first result is Microsoft documentation for LPC void. The documentation shows us that LPC void is defined as a void pointer. Type def const void pointer LPC void. To solve these errors, we can cast our address as a void pointer. The resulting code looks like. So if we want to, we can just do void pointer. That'll typecast our address as void pointer. It'll fix that instantly. With this, those errors will disappear. Now we can examine the second set of errors that occur on line 4, or in the find window call. Indicate that the battle was not string is not cast correctly. It is a const char. We could be cast as a LPC W string. To this, we can prefix starting with L or find window call. Now looks like this. They're using Unicode too. Since after making this change, the errors will disappear and we can now compile and execute our program. Do this, we go to the build menu item and select build solution. Once it's complete, we'll have a program that we can execute. For how this code works, we need to make sure that we can actually read correct values to the memory address. To do this, we will debug our program inside Visual Studio and compare the results of our read process memory call against CheEngine. First, open up CheEngine and manually add the address and set a breakpoint on the read process memory line. The thing is, this isn't going to be our actual address here. This is just the address. Because it's actually AC underscore client, which is get module handle thing. Let me see. I don't know if I don't know if this is gonna, because I'm not sure if this works with. I've never made my own memory, like getting functions. I've only ever used like pre-built ones, so kind of get module handle. Yeah, and we want to make help the unit pointer underscore to help is equal to do So H module base underscore address is equal to unit pointer help base underscore address plus 0x17e0a8 plus 0x-e3. Let me fix this real quick. Okay, and this should just be right. So I don't know if this is gonna work or not. I guess we'll just wait and see. Let's see what they do here. So to verify this code works and make sure that we actually reading the correct value at the memory address to do this, we will debug for programs that it will sit and compare the results of our read process memory call the cheat engine. Open cheating manually and add the address instead of breakpoint read process memory line. So yes, I already have this open. Let's go to cheat engine. Cube, load the process table. So with this, we can just take this right here, pointer, and then add EC at the end of it, and that will give our value. Their offsets. What the fuck? External reference and function and underscore CI on the name. There's really nothing else inside of here except for this. Just go see. There's an external symbol, so it means like countering external symbol usually occurs when you're building a product, but only you can't find entry point before in this case. It's looking for the one main function. The entry function? Oh, it's because I made. Well, I made this a Windows thing then I guess maybe I shouldn't have done that, I guess. Change back to console. That doesn't actually do anything because it just reads in. Oh yeah, so there's setting a breakpoint right here. Can't remember how to access the stack tab or maybe it'll show us right here. Click on the local Windows debugger button at the top of IDE and then begin your executing our program with debugger attached. Since we have written the source code, debugging our program will be far easier than debugging. See, how do I get my Windows? Close video, code, debug. Oh, okay, watch. This is what we're looking over here, right? How does this thing even work, bro? I got no idea how this thing works. We've written the source code debugging our program before using the debugging was not. When our breakpoint is reached, the debugger will pop and let us explore various elements of the code, including the as we show on the bottom of the IDE to make sure we're reading process memory correctly. We want to look at the gold value variable to make sure how it matches. Values matching over correctly reading the norm was not, but the continue button at the top of that 86 okay for the method. Now we can move on to finding our goal value. Did I even add a return? I didn't even add a fucking return, bro. Fuck. Health underscore value is 0. It should be 29. I don't think it's... Type unsigned. Okay. Well, yeah. I don't think... So that's basically the same thing. Health underscore value unsigned along. Yeah. Process underscore ID. Yeah, when I put process underscore ID. Process underscore ID. No, it's gotta be because the only thing different I did was making this. But I mean, I can just set it back to 0x17E088. That's not gonna get us anything though. Comment this out. Comment this out too. See, it's not just gonna be a valid address within the thing. But if I change it to this address, then it will be valid for this time around. Just change that real quick to see what happens. So yeah, so health value does get set at 29. That's because yeah, but then if I set it to that, it's not gonna do anything, even though because AC underscore client plus. I don't know how we. I do know how we do it. I can't remember though. Fuck, man, I can't remember. Dude, this is not gonna give us our health value, obviously. That's fucking given. Continue past this. It's gonna be some random shit. Yeah, I already know that. Let me try unsetting this again. That's not getting our base address there. Excuse me. I don't know how they do that, to be honest, externally, I can't remember. We can process it, we can retrieve our goal value and defeat game A lesson, we determine that our goal address is stored at. This can be further simplified to retrieve the value of our address, we can first with the value of, then add 0xA90 to that value. We can then read its address and add 4 to it. Once we've done that, we'll have our goal address. Wait, let me just check something real quick. Because it might all be fine. It's reading. It could be reading this value. I'm just gonna check this just in case. If it is, then we're chilling. No, it's not. Okay, I don't know. I'm lucky. Alright, well. Let's get this shit real quick. Human memory, we can now retrieve our gold value, and if you're doing a lesson, we determine that our gold address is stored at. Okay, we can read this address and add 4 to it. Once we've done that, we will have our gold address for this entire process. We use the function call identically to our previous code. First, we'll feed in the value 0x plus 0ax90. What? Use match, we can add a final offset of 4 to address to retrieve our gold address. We'll put that in there. Huh. Well, I wonder the thing that I don't have the thing that gives me the base address. We're just getting the window to the process. Let me look at my CS code real quick to see how I got the base address in there. I guess this is an external one for the theory. Where did I do it at? Was it up here? I use the get module handle. Oh dude, that's gonna be a lot of shit right there. Process module, get module. So this is where module underscore name const char allocate. Look at some super old code from a long time ago. Like where I had build memory, like the first thing that I did. Okay, yeah, get process ID. Const wchar proc name. I'm just gonna get module. So I need to get the module base address is what I need to do. Yeah, I'd have to do. I'd have to just. Okay, I can just copy and paste all this shit right here. Make a memory header file. Proc.h. I could just use this to get the process module name. It's time to do. 40 minutes into this shit. Okay. Okay, because we can't read any of these addresses that it wants us to read without having the base address of the thing. So yeah, that's all fucked up right there. I don't even know what I was in there. Get process ID. Get module. So I'm gonna need to do these two right here. So I'm gonna copy and paste these two real quick. Get module base address. Get process ID. Let's add Let's just add a new class called process or proc. Maybe another one. Add a new class. Call it proc. So in proc.cvp. So let's get so proc.cvp. Let's just grab all this. And then proc.h. Put this in here. Okay, this stuff we don't need. Okay, proc.cvp. That. Okay, now we can use get proc ID. Hashtag include proc.h. Now we get the process ID, the process ID of AC client, and then sure. And then we can do okay, then we can do get what do we have here before? Event pointer underscore t to help equals help address equals let's fix up my code here a little bit. Fix address process underscore ID equals get rid of that. So help underscore address is equal to module underscore base plus 17 0x plus 0x EC. Let's together first. Proc ID is undefined. This is process underscore ID. Okay, that should be the help address. Then we can do this. Help underscore address. And this should give us a help value. Let's take a look here. I fucking hoping to God it does. If it doesn't, I'm fucking pissed. It's not. Okay, what about help underscore address? 575 value of that either. Let's get rid of that real quick. Some pussy ass shit. Why is it doing that? It's not how it's supposed to be. Let me look at my external code real quick. This share here is dog Jesus. I think it's CS2 tutorial because figure reader. So we get module, get the module tutorials, whatever. So this is the reading function that I'm using here, which is pretty easy to use. With the unit pointer of the address. And then all it does is just put that into there. Wood pointer address. Read virtual memory. Hmm. So it's all different. It's kind of strange. We can look in reclass real quick. I'm pretty sure the base address. Yeah, it's just 0400. So I'm just gonna do. I'm just gonna get the base address myself. Let's do this plus 0, 0, 4, 0, 0, 0. Yeah, that'll be our base address for this. And then let's do that. Let me once again get back to this real quick. Let me sex this out. So what they do over here? So after they did that for the pointer, they then did the gold value plus equals to help underscore value. Right. Underscore value plus equals 0x EC. Just cut and paste to this. Oh, underscore value. Okay, I got it. Sweet. Okay, well, that was pretty easy. I just had to do some maths and stuff real quick. Sorry, I know that was like kind of retarded or something. I didn't even know it was good. Sorry, I'm just like I'm so unused to doing things from scratch that when I'm like looking at it and having to do it, it just kind of puzzles me because I'm like, why does this not work the way I think? That's what happens when you work with like pre-made code for so long. Like you don't know. I've always like just used a process to get my code form or not. I use the like memory header files, memory CPP files to do memory processing for me. And actually really had to think about it at all. It would just kind of get it for me, right? And not doing it like this. Like this is a very simple and crude way of doing it. I mean, it works, but yeah, we need to change it to examine offsets, ensure that we're reading the correct value, or no, we are. The value is matching at the final offset for write memory. The API to write into the process memory is called write process memory. Its definition is very similar to read process memory. Pass it a handle, the base address, the buffer inside. Okay, the major difference is that the function writes the value of a buffer into a section memory instead of reading such memory into a buffer like before. We need to declare two variables for the buffer and the number of bytes written. So let's just go here and copy and paste those, make this new underscore of underscore value. Okay. Then we can call write process memory in an almost identical manner to read process memory, like the read process memory will cast our goal value to a void pointer. So okay, cool. So this will just take our gold value right here, our more gold value's address, just pointing to the address of it. or it's pointing to the value of whatever's inside of it, and then give it our new value, which would be our. So here, let's just write underscore write process memory underscore process void pointer to help underscore value. We're gonna give it the value at the address of new underscore help underscore value. And we're gonna write 4 bytes and do bytes underscore written. Alright, that should be good. When this executed, our build will be set to 5 and 55 and our hack will be complete. Now run this executable whenever you want to change our build. That's distributed to other players execute on the machines. Code this lesson is available on GitHub. So if we run this, it stopped my breakpoint, didn't it? Or no, it didn't. I didn't add a so we can just go through here. I thought it was gonna be the same. Continue. So, oh wait, that didn't work for some reason. No. No underscore health value. We did everything right, I'm pretty sure. Yeah, that should matter right there. Set to release mode and run it. Health value 4 bytes written to. Oh, it's because we set our bytes written to 1 or 0, and then we can call it cross one something. I think our bytes written is set to 0. Set that. Bytes read is also 0. It's kind of strange how it's value plus equals C. Because we want to enter to our health value and we want to assign it. We need the base address. It's written to. So process underscore ID. They even ever set that, or they just left it as 0? Well, we're getting thread process underscore ID, but let me just set this back to 0 and then just throw it down here with these things. I doubt that's a problem because it's being overwritten over there, but plus already got the thing. Let me go in here and run this, but it's not doing anything. Let me go back to 555. Really bad on strap value. Value points to this. That should be working. I don't know why it's not working, to be honest with you. I can't put my finger on it. Let me go here and see this is rating item. Health value is being read. Hmm. I don't know. I have no idea why that's not working. What have I done wrong to make that not work? I don't. It's the same type widths and everything. It's not editing a health value like I would want it to. What if I just change it to this? And just not change the offset at all. Let me try that real quick, see if that works. Okay, so that worked, but the other one didn't. I knew it was just like fucked up. I don't know why that's fucked up like that, to be honest. Even though I did, whatever, it doesn't matter. Alright, well, I'm gonna make it the end of this video because that took a while. Just learning this like basic stuff that I had skipped over. Didn't bother learning because I'm retarded. But anyways, thanks for watching.